Hello all, welcome to this first lecture in this course on time series forecasting with applications in R. So in today's first lecture we will focus more on introducing what exactly is time series and how time series data is kind of different from any other data that you might have seen in, let's say, any of the other statistical courses. For example, let's say inference or be it regression or be it hypothesis testing and so on and so forth. And this first session will try to cover a lot of examples of different time series coming from different areas like ecology or be it finance or be it climate studies and so on. So here if you see we have a stock price of Apple and this is a very classic example of time series and all of you can appreciate exactly as to how time series behaves. So I think this is slightly old, it dates back to 21, so August of 2021 to the current month, and here you can see the behavior of the Apple stock as time moves, and down here you can also see the volume. So stock price, when somebody talks about time series, they kind of appreciate time series with certain stock price. And of course, like I said, down the line we'll talk about multiple other examples also. So before we give out any examples on time series, I'll give you a small question to all of you. So in front of you, you can see two options. The first one is a very simple one. So let's say you have x1, x2 up to x100 and these are, let's say, some random variables, and assume that these are the outcomes of some dice roll in, let's say, 100 rounds. And as opposed to that, if you focus on this second example here, let's say x1, x2 up to x100 be the closing prices of a particular stock, again for, let's say, some 100 consecutive days. So now the important question is, what exactly is the difference between these two options? So maybe I'll give you half a minute to think. Okay, so I think if you consider the first option, again all of these xi's are random variables. So if you roll a die, then one can expect that any number between 1 to 6 can occur, right? So all these occurrences are completely random in a sense that they are kind of independent to each other, right? But again, if you focus on the second series here, which is, let's say, x1, x2 up to x100, where all of these random variables are some closing prices of a stock, then one can actually assume that there has to be some inbuilt pattern in that, right? So for example, x2 and x3, or let's say x3 and x4, they need not be completely independent in a sense that all of these random variables, they kind of depend on the time frame or the time factor there. Okay. So this is, I think, very important and the foremost distinction between a time series data set and any other data set for that matter. So before we proceed, I'll give you a very quick example. So let's say in almost all the other courses, you must have seen random variables which are written down as x1, x2, xn, okay. And further what we assume is that they are coming from, let's say, some distribution. So I'll take normal, okay, with some mean mu and some variance sigma square, okay. And the foremost assumption that we make is all these are IID. So IID stands for independent and identically distributed. So I'll say that this is a classic example of a data set. So I'll write down classic data set. But then as opposed to that, if you transition into a time series, then how exactly a time series data is different is due to this time frame here. So I'll mention xt, and then the next observation would be something like xt plus 1 and so on up to whatever time frame you want to consider. So let's say the last one could be something like xt plus 10, okay. So if you see here closely, or if you observe closely, the first set is completely independent of each other. So any pair of random variables are independent. But when you talk about a time series set or time series observations, for example xt, xt plus 1 up to xt plus 10, then all these individual random variables need not be independent in a sense that all of these are dependent on that time frame t for that matter, okay. So of course in the later slides we'll see that how exactly you can change this time frame t. So we can have different situations pertaining to different focus areas. For example, T could be daily, or T could be weekly, or let's say T could be monthly, or T could be annual, right? So depending on what kind of data structure you have, one has the liberty to change that time frame notation T. So just to sort of summarize exactly what we discussed in the previous slide, so what exactly is time series? And the second point is how time series data is different from any other data. So the first point is classical inference. So classical inference covers any other data set which you might have used in some other course, let's say regression for example, or statistical inference for example, right? And as we discussed earlier, there the data is sort of assumed to be completely independent and identical. So identical means that all the random variables have to come from some fixed distribution, let's say binomial or exponential or normal, etc. But the moment you talk about time series data set or time series observations, the first point is that any time series data set is ordered. So there is a certain ordering in all the observations, right? So let's say x1, then x2. So x2, when you talk about x2, you are kind of assume that x2 succeeds x1. So let's say a simple example could be temperature data. So let's say x1 could be today's temperature, x2 could be tomorrow's temperature, x3 could be day after tomorrow's temperature, and so on. All right. So time series observations, there is a certain chronology in that. So data set is ordered according to time, or we can say that the observations are chronological. And just to summarize this question in red, it says that hence is time series data independent? So again the clear answer is no, right? So time series data is not independent because all the individual random variables, let's say xt, xt plus 1, xt plus 2, etc., they sort of depend on that time frame t there. Okay, so before we proceed, I'll give you a short overview of what kind of data types we have. All right, so the first very important data type is called as cross-sectional data. So I think cross-sectional data is any kind of data set that you might collect in a usual day-to-day situation. So let's say heights of students, or weights of different students, or ages of different students, right? But the key definition here is observations come from different individuals but at a single point of time. Okay. So again, just to repeat, any cross-sectional data, all the observations have to come from different individuals but at a single point of time. So the single point of time is sort of important here. So at any given time point, if you are collecting data set or if you are collecting observations from different individuals, we will say that the data set is cross-sectional. Okay. Now of course in the next slide I will give you some examples, but then the other kind of data set is time series data, and the focus of this entire course per se is especially on the second point, which is time series data. So what exactly is time series data now? So as discussed earlier also, that time series data is nothing but set of observations collected for a particular individual. So you are kind of fixing one individual or an entity over different time points. All right. So the differentiating point between cross-sectional and time series is cross-sectional is collected for different individuals at a single point of time, whereas time series data is collected for a particular individual or an entity over different time points. So now I think we'll discuss some examples of both kind of data sets. So the first one is cross-sectional, and then here you can see that you have examples coming from different areas. So the first one is, let's say, maximum humidity levels at 20 different locations in India on a particular day. So again, just to highlight, so we're talking about maximum humidity at 20 different locations on a particular day. So the time point is fixed here, and we are collecting data observations from 20 different locations. Or the second example could be something like the closing stock price of 20 stocks again on a particular day. Or one can talk about, let's say, heights of students in a class measured on a particular day. All right. So again, just to repeat that any cross-sectional data the key element is to fix the time point and then collect the observations coming from different individuals or different locations or different entities, etc. Now, as opposed to that, the second kind of data set is called as time series data set. So, the first example could be a very simple one, something like daily maximum humidity levels for a month. Okay. So, again just to elaborate on the first example here. So, here we are not fixing the time point. So, we are kind of transitioning the time point over a month, but we are talking about the daily maximum humidity levels maybe at a particular location. So, here the entity or the individual or the location is fixed, whereas we have to change or keep on changing the time frame. Or the second example could be something like the closing stock price of a stock over 6 months. Or the third one could be something like the quarterly student enrollment in a college over 5 years. Okay. So, again just to summarize very quickly, so differentiating point between cross sectional against the time series data is that in cross sectional data we sort of keep the time frame to be fixed, whereas we aim to collect observations or data sets from different individuals or at different locations or from different entities. Whereas when you talk about time series data, we are kind of shifting the time frame and we are collecting observations over a wide range of a time frame for a particular individual or a particular entity. Yeah, so I think this slide kind of summarizes what we talked about a short while back, that time series data focuses on the same variable over a period of time, while cross sectional data focuses on several variables at a single point of time. All right. So, I think I will give you one short description just to elaborate this point more, because understanding time series and exactly understanding as to how it is different from, let us say, a cross sectional data is kind of really important. So, even for all the other slides that we will talk about maybe later on, in all the other lectures the focus would be entirely on time series data set. So, if you are not very comfortable on understanding the difference between a time series data and a cross sectional data, then I think there could be some problems. Okay. So, just to give you a very simple example as to how a time series data looks like. So, maybe notation wise we talked about a short while back. So, let us say xt, xt plus 1, then xt plus 2 dot dot dot. So, here again if you notice, since this t is fixed, right, and then since this random variable x is fixed, what we are doing essentially is that we are collecting observations from a single individual. So, let us say x, but we are kind of changing the time frame. So, let us say t, then t plus 1, then t plus 2, then probably t plus 3, etc. Okay. So, let me mention that this is a time series data example, whereas in a cross sectional example I will write down x1, x2, x3 up to let us say xn. So, all these random variables, let us say you assume that all these xi's are different individuals, okay, and we are talking about finding the heights of all these individuals. So, let us say something like h1, h2, h3 up to hn. Okay. So, here what exactly is the series h? So, the series h could be heights of different individuals, but at a single time point. So, let me write down that these two pertain to not a time series data, but cross sectional data. Okay. Now, just a level up, so we have a data type which is called as panel data or longitudinal data. So, what exactly is that? And then how exactly is a panel data different from, let us say, cross sectional or a time series? We will discuss it now. So, panel data, what it means is observations on different cross sections over a time. So, one can actually assume that a panel data is sort of a combination of cross sectional data and a time series data. Right. So, let us say think of a very simple example which is mentioned here, the first one. So, let us say the annual cancer mortality rates of different Indian states during 2015 to 2023. So, a couple of points to mention here, or a couple of points to note here. Firstly, the observations come from different Indian states. So, we are not talking about a particular individual or a particular location. Okay. So, and on top of that, we are also changing the time frame. So, during what period? So, during 2015 to 2023. So, panel data is nothing but a combination of different cross sections over time. So, let us say a simple example pertaining to the first example could be, we can talk about different states, for example, Maharashtra or Delhi or Tamil Nadu or Jharkhand, etc. So, what exactly are the annual cancer mortality rates in these locations over that time period, alright. Or a second simple example to understand this panel data idea could be something like yearly sales of 10 companies over 10 years. So, again the same structure can be seen here, that we are not talking about a particular individual here, but sales of 10 companies over a wide time span, which is 10 years. Or there could be one more example, which is, let us say, daily maximum temperatures of 5 cities in India over a year. So, if you want to again link this panel data to either of cross sectional or time series, again just to summarize very quickly, is that panel data is nothing but a combination. So, think of a situation where you have different cross sections spread over the entire time frame. So, now I think we will talk about what exactly are the steps when it comes to analyzing a time series data. So, I think since we are just starting and this is the very first lecture, so I have highlighted a couple of very important points, because there has to be some structure to analyzing a time series data up to the end point. So, I think the very first point is you have to plot the data. So, if you gather any time series data set or you gather any time series observations, the very first step is to plot the data and analyze it to extract meaningful information. So, I will give you a very simple example. Let us say if you want to talk about Google stock price, so the x axis and the y axis. So, the x axis is naturally time and the y axis could be, let us say, Google price, Google stock price. And again this is a very hypothetical example. So, let us say the price moves something like that. Okay. So, since we have plotted the data, we can actually see that what patterns they are following. So, what patterns the Google stock price is following. Okay. So, just to elaborate more on this point, so one can actually see that, so initially in the very first stage the price is increasing. So, you have a sort of a trend here, right, and then probably in this period the price is not moving much. So, price is kind of stagnating and then again the price sort of jumps here. So, by plotting the data, one can actually analyze the data much more easily and then try to find out the underlying patterns in the data set. So, this should be the very first step. The second idea is to study the past behavior. So, what exactly do you mean by this? So, study the past behavior means that how has the Google price behaved in the past, or how has the Google price behaved in the history, because that will give you some idea as to how it will perform or might perform in the future. Okay. Now, the third point is to identify the underlying patterns and trends. So, trend is a very useful terminology when it comes to any time series lecture or time series course. So, the idea of trend is very simple. So, trend is any upward or downward movement of an entity. So, for example, here again coming back to this Google stock price example. So, initially we saw that the Google stock price was uptrending, right. So, you have a trend here and then you do not see any major trend here, but again down the line you again see a trend here. So, by this we see that the Google stock price was kind of trending initially, but not trending in the middle and again trending towards the end. Okay. So, one has to actually identify all these patterns. So, do you have a trend in the data, or do you have any repetitions in the data set, right. So, all these are kind of patterns which are very useful to analyze any time series data. And I think the last point is use past data for forecasting. So, ultimately the goal of any time series course or time series analysis is forecasting. So, forecasting is exactly similar to prediction. So, I am not sure if you have done any course on regression, but in regression we have a similar terminology called as prediction. So, predicting something in the future. Similarly, when you talk about any time series lecture, we will say that we have to forecast something in the future. So, for example, forecasting the Google price for the next 10 days or forecasting the Google price for the next month, alright. So, using past data for forecasting is the ultimate goal. So, broadly speaking, these are all the steps involved when it comes to analyzing any time series data. So, now that we have discussed some examples of time series data set, for example, the Google stock price or the Apple stock price which is there on the very first slide, and after understanding the fact that how can you differentiate between a time series set of observations vis-a-vis a cross-sectional data or any other data set that you might encounter elsewhere. So, now we will focus majorly on a few other application areas of time series. So, I think this slide is kind of important to kind of gauge on the fact that in what all areas can time series be applied, or in what all areas can the application of time series can be seen predominantly. So, for example, the first one is a very simple example to start with. So, let us say retail stores. So, retail stores can use it to forecast sales. So, let us say D-Mart or Big Bazaar, right. So, all these retail stores might use the time series analysis to forecast their sales. Now, when you talk about sales, the time frame here could be slightly different according to what goal the retail store has. So, for example, forecasting daily sales or forecasting monthly sales or forecasting quarterly sales or forecasting the annual sales, right. So, depending on what the goal is, the time frame can be changed here. Right. Now, the second example is, let us say, energy companies. So, energy companies use it to forecast reserves or their production or demand or supply or prices, etc. Educational institutions might use time series analysis to forecast student enrollment. So, let us say an institution like IIT Bombay can actually apply some time series modeling or time series forecasting techniques to kind of forecast as to how many students would enroll in the next semester or next year, etc. Or for that matter, international financial organizations, let us say such as World Bank or International Monetary Fund, might use time series analysis to forecast inflation or any other economic activity. The next example is, let us say, transportation companies. So, transportation companies might use time series analysis to forecast their future travel. So, the problem statement could be something like how many people would want to travel, let us say, in the next month at a particular destination, or how many people would want to take a vacation in the coming summers or in the coming winters. So, it is a very valid problem statement. Or let us say banks and lending institutions might use it to forecast new homes purchases. Or let us say venture capital firms might want to apply some time series techniques to forecast their market potential and vis-a-vis evaluate the business plans, etc. Or the last one is again a simple example. So, let us say weathermen might use time series analysis to predict precipitation, temperatures, humidity levels, etc. So, I will say that time series finds its application in numerous areas such as, let us say, finance or climate studies, environmental sciences, etc. So, now I think in the next couple of minutes or so, we will discuss what exactly do you expect in this course. So, I have just prepared 2 slides on this and we will go week by week just to understand the fact that what advancements can we talk about here. So, naturally in the first couple of weeks, we have a small introduction which we are kind of continuing now also, and then there is a concept called as stationarity in time series. So, we will discuss that. Then we will talk about some basic time series models to start with, moving average, autoregressive, etc. And then we will wrap up the first couple of weeks by talking majorly about non-stationarity. So, almost 90% of the examples that you see in the real life are not stationary. So, then when you transition into the other weeks, so weeks 3 and 4, so we will talk about some tests for stationarity, some other advanced models such as ARIMA, SARIMA, and then model identification. So, how to identify the correct model. And then later on in weeks 5 and 6, we can focus more on, let's say, forecasting methods, then comparing forecasts. So, how would you compare two different forecasts which you have applied for the same time series and then pick the better one. Then you have a topic called as fractionally integrated processes. So, we will spend some time there. And in week 7 and 8, we will focus more on multivariate processes. So, multivariate time series, then co-integration. So, how are two time series co-integrated, and some causality analysis. Then down the line in weeks 9 to 10, we will focus on Fourier transformation. So, I think this week would be kind of interesting, where we will transition into a slightly different angle of looking at time series data sets, which is Fourier transformation or spectral density, and then volatility modeling. So, models like ARCH or GARCH, they will appear here. And in the final weeks, we will spend some time on non-linear models, or let us say Markov switching models. And then ultimately, we will talk briefly about machine learning models. So, these days people are more interested in kind of mixing or applying some machine learning modeling techniques into, let us say, analyzing some data sets and so on and so forth. So, we will spend some time on machine learning models and applications using a time series data. So, let us say neural networks or decision trees or reinforcement learning, etc. So, I think this is a very brief outline about how the course will progress down the line. And of course, in each of the weeks, there will be a small component of some practical things in R using the R software. And again, in the subsequent lectures, I will give you a short overview of R as well. So, if somebody who is not very confident in applying R or analyzing using R, they should not worry. So, we will discuss that in brief. Thank you.